PUTNAM 1999 A4 series problem. So this problem appeared in PUTNAM, and this problem is kind of easy problem, so that's why I was able to solve, and that's why I'm able to bring out to you guys. You can give this a try and maybe you solve it on your own. It's not too hard. And let's see how do we solve this problem. So basically over here you can see that the expression over here is kind of symmetric. It's actually symmetric, yeah. And these over here are not, yeah, these two like break the symmetry. And also notice that both m and n are going from 1 to infinity and 1 to infinity, yeah. So like, what if we try to interchange the m and n variable? Yeah, like the sum will not change. Basically keep the limits same and interchange m and n, the sum will not change. And you can try experimenting like changing these two and adding these two and making some manipulations. Yeah, those are some common techniques. Yeah, and I also tried that. So basically, since m and n are going both from 1 to infinity, I tried interchanging m and n, and then I tried to see if any manipulations I can make that can be helpful. Yeah. So this will I can also write this as n square m by 3 to the power n, m 3 to the power n plus n 3 to the power m. The expression in the bracket is the same, and these are interchanged, and both are s. Yeah. Okay. Now if we try to sum them up and see what's going to happen, we are going to be surprised, just like me. So 2s will now be sum from m equals to 1 to infinity, sum from n equals to 1 to infinity. Over here we can take the same denominator and then add the numerators. Yeah, m square n by 3 to the power m plus n square m by 3 to the power n by m 3 to the power n plus n 3 to the power m. Now try taking the LCM over here. 2s is equals to sum from m equals to 1 to infinity, sum from n equals to 1 to infinity. Now if you take the LCM, you will have, or you can you can take mn common as well, and then take 3 to the power n, 3 to the power n as LCM, and then what will remain? M 3 to the power n plus n 3 to the power m will remain. And this is exactly the thing that's there in denominator, and that is pretty awesome because now it's simplified a lot. You can cancel this too. Yeah, and now this simplifies, and now it's in like obvious evident problem. You all know what to do next. Yeah, it's not too hard now, because now you have m by 3 to the power m and n by 3 to the power, oh this is n, I'm sorry for that. Okay, n by 3 to the power n. Now you know what to do. This is 2s is equals to, you can like distribute to individual sums, yeah, and both sums will actually have the same answer. So let us write one of them and just square it. M by 3 to the power m, and also other sum also from n equals 1 to infinity, n by 3 to the power n, both are same, so squared. Now this is a pretty evident like problem. Basically you just have to find the sum of an arithmetic or geometric series. Yeah, m equals to 1 to infinity, let's say m times x to the power m. You have to find the sum of this series, and x over here is 1 by 3. Yeah. Now what do is you can begin with the geometric series. Sum from, let's say, m equals to 0 to infinity of x to the power n, x to the power m. And we know that if the modulus of x is less than 1, this is 1 by 1 minus x. Yeah, if you differentiate both sides, you get sum from m equals to 0 to infinity m x to the power m minus 1. If derivative will be 1 by 1 minus x whole square. Basically minus times minus 1 will just be 1 itself. Now multiply both sides by x. Also notice that m going from 0 and the first term will be 0, so we can take m actually from 1 to infinity. 1 to infinity, and if you multiply this by x in both sides, we will have this expression. So we see that if the modulus of x is less than 1, in that case this sum over here is x by 1 minus x whole square, and just use the formula now. So this sum over here will also be okay, so this sum m equals to 1 to infinity of m by 3 to the power m. Here x is 1 by 3, will be x by 1 minus x whole square. Yeah, and x is 1 by 3, so 1 by 3, this 1 minus 1 by 3, 2 by 3, so 2 by 3 whole square is 4 by 9, 9 by 12. Yeah, this is 3 by 4. Yeah, and now this is 2s is equals to 3 by 4 whole square, and that is 9 by 16, so s is 9 by 32, and we get our answer. So that was it. To talk about the problem, we just tried interchanging the variables because the sum will remain same, and then we tried to add them to see if anything happens, and a thing happened, it cancelled out and simplified, and now we break it to individual sums. And to find this was an easy thing because it is a well-known like arithmetic geometric series. It can be found from the differentiation of a normal geometric series, and we got the answer. So that was it, and this is how we solve the PUTNAM problem. Hope you enjoyed the solution. Thanks for watching, and look forward to seeing you in the upcoming videos too.